In Lesson 12, we're going to be looking at the greatest common factor. So if we look at the directions, it says the greatest common factor of two whole numbers, A and B, written GCF. So anytime you see GCF, that stands for greatest common factor, is the greatest whole number, which is a factor of both A and B. There are two different methods that you can use to calculate the greatest common factor, or the GCF. We can use the list method or the ladder method. The list method is probably pretty familiar to you, and the ladder method may be new to you, but I feel like we're going to want to use it because it makes it nice and easy. So let's look at what all of this means. It says find the greatest common factor, which again is going to be the GCF of 12 and 18. So with the list method, we take each of the numbers and write them down with colon next to them. Then what we're going to do is list out all of the factors of each of the numbers. And remember, factors are numbers that multiply together to give you a product. So we're looking for all the numbers that multiply together to give us 12. I like to list them out. We typically list them out numerically. So I'm going to start with 1. 1 is a factor of every single number. 1 times the number itself will give you that number. So I start with 1 and then the number itself, 1 and 12. And I give them some space in between. Then I go to 2. 2 can go into every single even number. And since 12 is even, 2 would be on our list. I know 2 times 6 is 12. So next to the 12, I would put the 6. Then I would look to see if 3 can go into 12. Hopefully, knowing your facts, you know that 3 can go into 12, and 3 times 4 is 12. Since the next number I would try on my numerical list is 4, and it's already there, my list should be complete. You have to really be careful to make sure that you get all of your factors, because this can throw off your GCF. And this is why I highly recommend using the ladder method, which we'll see in a minute. But a lot of times kids will think they have all of the factors and they're missing a pair, which really throws this off. Moving on, let's look at 18. So 1 and 18 are the first numbers on the list. It is even, so 2 goes on the list. 2 times 9 is 18. 3 is the next number I'm going to try, and it can go into 18. 3 times 6. If I look at the next number on my list, it would be 4. 4 does not equally go into 18. 5 does not equally go into 18. The next number I would try is 6, but it's already on the list, so this would be a complete list. So these are the factors for both of these numbers. I am looking for the greatest common factor, so the greatest number that they both have in common. So I usually start at the greatest side of the list, okay? Nothing in common here. The 12 doesn't have a 9 on it. Going to the next number, they both have a 6 on it. So 6 is the greatest one that they have in common, and that's our GCF. Now, looking at the ladder method, like I said, with the list method, it's very easy to make mistakes. So this ladder method is another way that you can find the GCF of 2 or more numbers. So I start my ladder by writing the 2 numbers separated by a comma. Then what I do is I make a division bracket, but kind of upside down like this. What I'm going to do next is I'm going to think of a number, and it can be any number that goes into both 12 and 18. Let's say we look at this and we say, oh, they're both even. They can both be divided by 2. I would put 2 outside the upside down division bracket, and I'm going to divide it into both numbers. So 2 goes into 12 6 times, 2 goes into 18 9 times. That leaves me with a 6 and a 9. I'm going to repeat the same process that I just did. So 6 and 9 can both be divided by 3. I'll make another bracket, I'll put the 3 outside, and I'm going to say 3 can go into 6 twice, and 3 can go into 9 3 times. Now I'm left with a 2 and a 3. Since 2 and 3 can't be divided by anything but 1, this is where my ladder would end. Okay, so at this point I would stop. To find the GCF of the two numbers, you take all of the numbers down the side, so just along the side here, and multiply them together. Okay, and that would give you your GCF. Notice it's the same we got from the list method. Now I want to show you, it doesn't matter what number you start with or what process you go through, you're still going to wind up with the same thing. So let's say I said, oh, 12 and 18 can both be divided by 3. Put the 3 out here. 3 goes into 12 4 times. 3 goes into 18 6 times. 4 and 6 can both be divided by 2. 2 goes into 4 twice. 2 goes into 6 3 times. 2 and 3 don't have a common factor besides 1. So take the numbers down the side and multiply them together. Let's say I looked at the two numbers and I said, oh, they can both be divided by 6. 6 goes into 12 2 times. 6 goes into 18 3 times. 2 and 3 don't have a common factor besides 1. I only have one number down my side, so that's my GCF. No matter which method you go about doing this, you wind up with a GCF of 6. Okay, we're going to try another one. Find the greatest common factor of 20 and 24. So with the list method, I would list out all of the factors. 1 and 20 would start us off. 20 is even, so 2 goes on the list. 2 times 10 is 20. 3 does not work. 4 goes into 20 5 times. And since 5 would be the next number I try, my list should be complete. Down to 24, 1 times 24. It's even, so 2, and it's 2 times 12. 3 also goes into 24 8 times. 4 goes into 24 6 times. And 5 does not go in. The next number on my list would be 6, and it's already there. So again, if you have a hard time listing out the factors, I would recommend the ladder method. Looking at these two lists, the greatest number that they have in common is 4. Using our ladder method, 20 and 24, again, you can start with any number that goes into both of them. Let's say we chose to start with 2. 2 goes into 20 10 times. 2 goes into 24 12 times. 10 and 12 can both be divided by 2. 2 goes into 10 5 times. 2 goes into 12 6 times. 5 and 6 don't have a common factor besides 1. So take the numbers down the side, multiply them together, and get the 4 that way. Could have also started with the 4, still get the same bottom two numbers, and then it's just one number down the side, which is your GCF of 4. Okay, let's look at another one. This time we're looking at a word problem. This one says Mrs. Smith is making goodie bags for her team day party. She has 30 lollipops and 45 pieces of gum. She wants to have the same number of lollipops in each bag. She wants to have the same number of pieces of gum in each bag. What is the greatest common factor, greatest number of bags that Mrs. Smith can make? How many lollipops will go in each bag? How many pieces of gum will go in each bag? So once again, we can use either the list method or the ladder method. I'm actually going to skip the list method and go straight to the ladder method for this one. Notice it's asking the greatest number of bags, so that's telling me greatest common factor. I'm going to use my 30 and my 45. I see one ends in a 0, one ends in a 5, so my mind automatically jumps to 5. 5 goes into 36 times. 5 goes into 45 9 times. 6 and 9 can both be divided by 3. 3 goes into 6 twice. 3 goes into 9 3 times. 2 and 3 don't have a common factor besides 1, so to find my GCF, take the numbers down the side and multiply them together. So that means that the greatest number of bags that she can make is 15 bags. It's now asking how many lollipops will go in each bag and how many pieces of gum will go in each bag. Two different ways you can do this. For the lollipops, you would take the number of lollipops and split them up over the number of bags, which is 15, and get 2. For the gum, you would take the total pieces of gum, divide it up by the number of bags, and get 3 pieces of gum in each bag. Another way to look at this is if you're doing GCF, if you label the lollipops and the gum here, the number at the very bottom underneath each one is your answer to that follow-up question of how many in each. So for lollipops, it ends with 2. Notice the 2 here. With gum, it ends with 3. Notice the 3 here. The next one's another word problem example. The PTA is making fruit baskets to sell at their winter fundraiser. They have 27 apples, 36 bananas, and 18 pears. And they want each bag to have the same number of apples, the same number of bananas, and the same number of pears. What is the greatest? There's our greatest common factor again, number of fruit baskets that they can sell. How many apples will be in each bag? How many bananas will be in each bag, and how many pears will be in each bag. Once again, I'm going to skip over the list method. If you prefer it, great, use it, not an issue. You just have to make sure you know all of your factors of these 3 numbers. I'm going to show you how it works with 3 numbers for the ladder method. So I'm working with my 27 apples, my 36 bananas, and my 18 pears. What I have to do is I have to start by finding a number that can go into all 3 of these. Okay, so I have to think of something that can go into 27, 36, and 18. Looking at these, I know that 3 can go into each of them. So I would put 3 out here. 3 goes into 27 9 times. 3 goes into 36 12 times. And 3 goes into 18 6 times. Okay? Looking at 9, 12, and 6, all 3 of them still have a common factor. They can all 3 still be divided by 3. 3 goes into 9 3 times, 3 goes into 12 4 times, 3 goes into 6 2 times. At this point, 3, 4, and 2 do not have a common factor. Even though 4 and 2 have a common factor, since all 3 don't, I am done. So I'm going to take the numbers down the side, multiply them together, and get my 9 that I would have for the number of fruit baskets they can sell. The next piece was how many apples, how many bananas, how many pears in each one. So for apples, I would take the total number of apples and divide it by the number of bags, which is 9, and get 3. Or apples ends with 3. Bananas starts with 36 total, divided by the 9 to get 4, or again, bananas 4. And then pears, 18 divided by the 9 bags to get 2, or same directly underneath at the bottom. Now, just a little note here, if a set of numbers doesn't have any other common factors, the GCF is 1. So for example, if I had 3 and 5, nothing can go into 3 and 5 besides 1, so then 1 would be the GCF.